Calculus 12. You've made it all the way to the pinnacle of high school mathematics. Congratulations. So, you've got a lot of work ahead of you here in calculus, but hopefully these videos will help you get through it. We're going to start actually by doing some review of PreCalculus. If you understand all this stuff, then skip it. But I think I'm doing it over 4 or 5 days. I'll do a bunch of review. And the other thing I'll do as I'm doing the review is I'll let you know how important it is for your success in calculus. So for example, the first thing I'm going to review is factoring. This is really, really important. You just have to know how to factor. And I bet by now you do. So let's go ahead and practice factoring here. The first question we have is 2x to the fourth minus 2x squared minus 24. And as you know, the first thing you always want to do when you factor is to try to take out a greatest common factor. And there is a greatest common factor in this one, isn't there? It is 2. So we'll take out the 2 and we're left with x to the fourth minus x squared minus 12. Okay, this is a trinomial, and you know how to factor trinomials, especially when the leading coefficient is 1 like this one. It's a little bit strange because you do have this 4 and 2 here. You're used to having 2 and 1, right? But that's okay, as long as it's half as much, as long as it's 6 and 3 or 4 and 2 or 10 and 5 or whatever, you actually just follow the same rules as before. So I'll show you what I mean. What you're going to do is you're going to keep that greatest common factor. You're not going to lose that. You know that when you do this, you usually split it into 2 brackets, right? And usually you'd put x and x here to get the x squared term. But here we have an x to the fourth. So what are you going to put instead? You're going to put x squared and x squared. Great. Now what are we looking for? We're looking for two numbers that multiply to 12 and subtract to 1. That's the way I teach it. I know it's kind of a trick. It's not totally mathematical. If you want totally mathematical, what you're looking for is two numbers that multiply to negative 12 and add to negative 1. But I find students are so bad with negatives that my method kind of works a little better. Two numbers that multiply to 20 and subtract to 1. Oh, that's 4 and 3. So another trick, if you want, you can drag down the first sign and put the larger number. Remember our numbers are 4 and 3. Put the larger number right there. You can always do that. Drag that sign down, larger number. Now the other number we said was 3. You got to think here. Is it negative 4 times negative 3 equals the negative 12? Or is it negative 4 times positive 3 equals negative 12? It's positive 3. There we go. Are we all done? Actually, we're not. You have to look at what you've got factored and see if you can factor it any further. And you can factor this even further. This is a difference of squares, isn't it? So you're going to keep the 2. You're going to keep the x squared plus 3. I guess I could write that out here. And x squared minus 4 is a difference of squares. So you're going to have 2 more brackets. What multiplies by itself to get x squared? X and x. What multiplies by itself to get 4? 2 and 2. And what's the rule with the signs in difference of squares? You do the opposite signs. So you got a plus, you got a minus. Doesn't matter the order you put those in. Okay, why can't you do the same thing with this, the x squared plus 3? Because of that plus. It has to be a difference of squares, and difference means take away, right? So that's why it would work in this one, because of that takeaway sign right there. Okay, let's move on. Second one, 8x squared plus 10x minus 3. So we try to take out a greatest common factor. There's nothing. So this is where we have a coefficient other than 1, a leading coefficient other than 1. So this is what I call Bobby Bridge. I know that's, again, not mathematical at all, but I just choose to remember my wonderful old student Bobby, who thought of this looking like a bridge. So Bobby Bridge, and to do Bobby Bridge, you multiply the 8 and 3 together. You get 24, or if you want, negative 24. But again, I'm going to use my little trick. I'm looking for two numbers that multiply 24 and subtract to 10. So you have to be careful here, because if you just see the 24 and 10, you think it might be 6 and 4. 6 times 4 is 24, 6 plus 4 is 10. But it's not 6 and 4. How come? Because it's two numbers that subtract to 10. What are two numbers that subtract to 10 and multiply 24? 12 and 2. So those are the numbers you should be using. So we're going to decompose the 10x, right? We're going to turn it into plus 12x and minus 2x. Those are the two numbers we said we had, the 12 and the 2, and the minus 3. So basically what we've done here is we've taken that positive 10x and we've split it up into positive 12x and negative 2x. If you combine those two things, the positive 12x and the minus 2x, you would have positive 10x. So we've just rewritten that positive 10x in a different way. What's our next step? We pair them up. We take a look at the first two and we take the greatest common factor. Greatest common factor of these first two terms is 4x. That leaves us with 2x in the first one. And 4x times what equals 12x? 3. Okay, now we look at the second pair. Negative 2x and negative 3. The greatest common factor is negative 1. When we take negative 1 out of here, we're left with 2x and positive 3. Be careful, it's a common mistake there. Negative 1 times positive 3 equals negative 3. I feel very confident I've done this right. How come? Because I have 2x plus 3 in each one of these terms here. So I'll factor out a 2x plus 3, and what's left here is 4x, and what's left here is a minus 1. Anything else we can do? No, we're done. Third one, negative 20x squared plus 5. A good rule is when you're looking for your greatest common factor, if the leading coefficient is negative, factor out a negative. So you could think that your greatest common factor here is 5, but I would make it negative 5. It'll work out better. So if you take out negative 5, you're left with positive 4x squared and negative 1. Finished? No, this can be factored. It's a difference of squares. So what do you multiply by itself to get 4x squared? 2x and 2x. What do you multiply by itself to get 1? 1 and 1. Make one of them positive, make one of them negative. Doesn't matter the order. Finish. Nothing else you can do. And the last one, this one confuses people sometimes because there's 4 terms. We don't see this very often, but there is somewhere you see 4 terms. You know where it is? Right here. This is where you have 4 terms. That's basically what's happening here. You're just kind of like you're partway through Bobby Bridge. So you're just going to go ahead and pair them up. Now this won't always work. Maybe it's not factorable, but in this case it is. You're going to pair up the first 2, pair up the second 2. So let's see what happens when we do that. In the first pair, the greatest common factor is x, and we're left with 2x plus 5. In the second pair, the greatest common factor is negative 1. We're left with 2x plus 5. Great, we got the same thing here and here, so we'll factor that out, the 2x plus 5, and we're left with x minus 1. All done. Egad, I forgot to circle this one. Can you imagine? Wow. Okay, moving on. Simplifying rational expressions. This is of moderate importance, I would say. Moderate to high. It's definitely important. Don't get me wrong. Don't skip this. We'll see things later that really aren't that important in the big scheme of things of calculus. This is important, but not quite as much as factoring. Okay, rational expressions are things in fractional form, right? And we're subtracting here. So basically you're subtracting fractions. When you subtract fractions, what do you need? You need a lowest common denominator. You're also going to take an NPV. You're going to figure out the NPV. What's NPV? Non-permissible values. In other words, what can x not equal here? Well, to figure out the non-permissible values, what you do is you look at the denominators and you ask yourself, what would make this denominator equal 0? What would make that denominator equal 0 is if x is 0. What would make this denominator equal 0? If x was 0. So our non-permissible value is actually only one of them, is that x cannot equal 0. It's not allowed for x to equal 0. Lowest common denominator. We've got 2x and we've got x squared. Well, we've got a 2 here and there's a coefficient of 1 there. So what's the lowest common denominator of 2 and 1? 2. So 2. And then we've got x and x squared. What's the lowest common denominator of x and x squared? It's always going to be the biggest exponent, right? So if you've got x to the 1 and x to the 2, it's going to be x squared. Okay, so same rules as when you normally add and subtract fractions. You need lowest common denominator of 2x squared. So you're going to turn this first fraction here into something with a denominator of 2x squared minus, you're going to turn the second one into a fraction with 2x squared in the bottom. So the question you have to ask yourself is, what do I multiply 2x by to get 2x squared? You got to multiply it by x. And what you do to the bottom, you do to the top. So we're also going to multiply this by x, all of that by x. Over here, what do we multiply x squared by to get 2x squared? We multiply it by 2. What we do to the bottom, we also do to the top. We have to multiply this by 2. So what happens now? Well, we're going to go x times x, and we're going to go x times 4. So we have x squared plus 4x. How about over here? This isn't squared, this is times 2, right? So you're going to go 2 times x, which is 2x, and 2 times negative 1, which is negative 2. Okay, very common problem here is because of this minus sign right here. This minus sign means you're subtracting all of this stuff. So our new denominator is just 2x squared. And what we have on top is x squared plus 4x. I'm actually going to put it in brackets. That's the first bit, minus all of this second bit, the 2x minus 2. That makes a big difference having that in brackets like that. And it's so common that people forget. They think this is minus 2x and then minus 2. It's not. It's minus 2x and minus minus 2. So please be careful about that. Okay, so I know I'm doing more steps than you'll probably do, but I have x squared plus 4x minus 2x and then minus minus 2, which means plus 2, all over 2x squared. We're almost there. We can combine those two middle terms. So we get x squared plus 2x plus 2 all over 2x squared. Now, you should, before you decide you're finished, look at that trinomial up there and decide, can I factor that? So I'd be looking for two numbers that multiply to 2 and add to 2. Any such thing? No, we're finished. And remember, we have a non-permissible value of x cannot equal 0. So in some cases, you might need to add on to this answer that x cannot equal 0. Depending on the context of the question, you might need to slap that on at the end. At least be aware of it, that what we've done is we've simplified this expression into a different form, and this will work for any value of x except when x is equal to 0, because x isn't allowed to be 0. Okay, this one is never too popular with people, but we better do it. So we're dividing rational expressions here. The first thing you need to do is you need to factor all of these. So we got a whole bunch of simple trinomials. Let's do it pretty quick. Two numbers that multiply 24 and add to 11 are 8 and 3. So we have x plus 8, x plus 3. Two numbers that multiply to 56 and add to 15 are 8 and 7. So x minus 8, x minus 7. Two numbers that multiply to 12 and subtract to 1 are 4 and 3. So x minus 4 and x plus 3. And two numbers that multiply 28 and add to 11 are 7 and 4. So x minus 7 and x minus 4. Okay, now what is the rule when you are dividing fractions? The rule is that you flip the second one and you multiply. So we're going to rewrite this. Again, I know you're probably rolling your eyes and being like, come on, man, like, why are you taking so many steps to do this? But I just want to make sure everyone understands this. So I'm sorry if you feel like I'm taking too long, then fast forward or something. But I'm going to do it. So I'm flipping the second one, reciprocal, right? And I get this. At this point, probably a good idea is to figure out our NPVs, non-permissible values, and there's quite a few of them that x cannot equal, because you have to look at every situation where you have x in the denominator. So if I look here, I have 8, can't be 8, can't be 7 here, can't be 7 here, and it can't be 4 there. So 8, 7, 4. But here's the thing. Once we flip this second fraction, I have some new ones. I have this one, which is 4, but I also have this one, which is negative 3. So make sure, this is common that people skip this step right here. They go straight to this step, the final step I have there. That's fine, but don't forget, you're going to have to include these non-permissible values there, even though they end up in the numerator here. It's any place that a term was in the denominator that you have to consider non-permissible values. Okay, now what we can do is we can start crossing stuff off. This is the best part, right? We got a minus 4, x minus 4, and x minus 4. They can be in the same fraction, that's fine, so I can cross those out. They can also be in different fractions, as long as one's on the top, one's on the bottom. So I can cross off the x plus 3 and the x plus 3. Hey, an x minus 7 and an x minus 7. I'm left with x plus 8 and x minus 8. Can I cross out the 8s? No, that's another very, very common mistake in math. People think you can cross out parts of binomials. No, the only way you can cross a binomial out, like I did in all these cases, and when you have the exact same binomial somewhere else. These are not the exact same binomial, so there's nothing you can do. Final answer is x plus 8 over x minus 8. And again, you might need to or want to include your non-permissible values. This is true as long as x does not equal 8, 7, 4, and negative 3. Simplifying complex fractions. Important, quite important actually, in calculus to know how to do this. So complex fractions are fractions in fractions. Looks pretty scary, doesn't it? But the most important thing to remember is that this line right here means what? It means divide. So if you want, there's actually different ways to solve this, but if you want, one way you can do this is treat this, the top part, separately from the bottom part. Get an answer here, and then just divide the two. That's kind of the way I usually do it. So what I might do is rewrite the top. This is 3 or 3 over 1 plus 9 over x minus 3. And I'm going to get that answer, and I'm going to divide it by 4 over 1 plus 12 over x minus 3. So we're adding here. We need lowest common denominators. And the lowest common denominator of 1 and x minus 3 is x minus 3. So what do you have to multiply 1 by to get x minus 3? X minus 3. And what you do at the bottom, you do the top. So I have to multiply 3 times x minus 3, and then I still have the plus 9. Similarly over here, I need to get my lowest common denominator, which is x minus 3. It's also x minus 3. So we're going to have a denominator of x minus 3. Now, what do you have to multiply 1 by to get x minus 3? X minus 3. So I also have to multiply the top by x minus 3. So 4 times x minus 3. The 12 already has x minus 3 as its denominator, so we're just going to add 12. Okay, now we will distributive property, or mountains, as I say to my grade 8s and 9s. And what do we get? 3 times x is 3x. 3 times negative 3 is negative 9. Plus 9, oh, I like the look of that, over x minus 3. Divided by 4 times x is 4x. 4 times negative 3 is negative 12. Plus 12, I like the look of that too, all over x minus 3. Okay, let's see, we can simplify this. I know, again, I'm doing this in way more steps than you will, but what the heck. Negative 9 plus 9 cancels, so I have 3x over x minus 3, divided by negative 12 and plus 12 cancel, so I'm left with 4x over x minus 3. This is another division question. So the next thing I need to do is need to rewrite this. I'm going to flip the second fraction, reciprocal, and multiply. So I have 3x over x minus 3 times x minus 3 over 4x. This might be a good time, it is a good time, to look for our non-permissible values. So remember, we're looking for anywhere that something was in the denominator. So if I look here, 3, 3, 3, 3, 3, 3, 3, 3, 3, and you might have missed this one, but once you flip it, you now have a 4x in the denominator. So this means that x can also not equal 0, because 4 times 0 equals 0. So our two non-permissible values are 3 and 0. Okay, let's finish this off. We get to cross out this and this. And we also get to cross out, now these are monomials. Remember I said you couldn't cross out like just the 3 and just the 3 there. You can only cross out entire binomials. But when you have monomials, you can cross out parts of them. So I can cross out the x and x there. So those are gone. And what I'm left with is 3 over 4. Wow, that's pretty great. We have simplified this huge mess right there. We've simplified that huge mess and said that for any value of x that you put into there, you're always going to get the value 3 over 4. Except for which two values will it not be true? If x equals 3 and 0, that won't be the truth, because for those ones it's not allowed. You'll get an undefined answer. Solving equations, very, very, very important, of course. So solving equations, if it's quadratic like this is, I think these are all quadratic, you make it equal to 0, and then you factor. And greatest common factor here is x. So I take out an x, I'm left with x minus 5 equals 0. Remember the zero product property? It says if you're multiplying two things or three things or four things or whatever, if you're multiplying them together and you get 0, then you know either one of those things equals 0 or both of them equal 0. So what would make this one, I'm going to put it in brackets to, you don't have to, but just so you can see what I'm talking about, what would make that first bracket equal 0? Well, if x equaled 0. What would make the second bracket equal 0? If x equaled 5. Those are my answers. Finished. Next one. This, you could expand this. A lot of people want to do that. It's a lot more work than you need to do, though. You could expand the whole thing and subtract 50 and try factoring and blah, blah, blah. But the other thing you can do is you can use the square root property here. We can isolate the squared bit. This x minus 5 squared, we can isolate it. How do we do that? All we have to do to isolate it is move the 50 over. The negative 50 moves over and becomes 50. Now, I want to undo the squaring. What do I do to undo a square root? But remember, when you solve equations and take the square root, you have to put plus minus. So, very, very quickly, if I just ask you what's the square root of 9, you say 3. You don't say plus or minus 3. But if I say, hey, here's an equation, x squared equals 9, and you want to solve that by taking square roots, then you do have to put plus or minus, so you'd get plus or minus 3. Okay? So when you solve equations by taking square roots, you must put plus minus. Alright, we're left with x minus 5, because the square root of a squared term is just the term itself, equals plus or minus root 50. But let's get that in simplest radical form. Remember making your little tree here, like 25 and 2 and 5 and 5. Oh, there's a pair, so that comes out of the radical sign. 2 stays in. So you have plus or minus 5 root 2. Now I want to isolate the 5. Or sorry, we want to isolate the x. So move the negative 5 over. You end up with that becoming positive 5 plus or minus 5 root 2. How many answers is that? That's 2 answers. One's 5 plus 5 root 2, the other one's 5 minus 5 root 2. You could factor out a 5 if you want there, but I think this is fine. Okay, next, this one you will need to expand to start. You have to expand this out. So 2x times x, 2x squared, 2x times 1, 2x. And what we want to do is we want to make it equal to 0. So at the same time, what you might want to do is move these two terms over. So minus 7x, and then the minus 2 comes over and becomes plus 2, and I'm left with equals 0. Now, why wouldn't I have moved all these two terms, over to the right? Because that would have made our x squared term negative, and we don't want our x squared term to be negative. So this is better to do this. Let's combine terms. 2x squared, 2x minus 7x is negative 5x plus 2 equals 0. Uh-oh, we can't factor anything out. We're stuck with this 2 out front. We're doing Bobby Bridge. So what we want is two numbers that multiply to 4 and add to 5. Multiply 4 and add to 5, that's 4 and 1. So let's decompose the negative 5x into negative 4x and take away another 1x, and then we've done it. We've decomposed negative 5x into these two terms. Keep our plus 2, and away we go. Pair them up. Greatest common factor of the first two is 2x, and I'm left with x minus 2. Greatest common factor of the second two is negative 1, and I'm left with x minus 2 equals 0. This looks good because I have an x minus 2 in both, and 2x minus 1 in the second one here. Alright, now we have zero product property. What would make this first one equal to 0? If x was 2. What would make the second one equal to 0? If x was 1/2. If you don't know how I got 1/2 here, set 2x minus 1 equal to 0 and solve that. So go 2x minus 1 equals 0, move the 1 over, you get 2x equals 1, divide by 2, whoa, you get x equals 1/2. What a mess. Hopefully that makes sense. Okay, another quadratic. When we solve quadratics, we set it equal to 0 and keep the x squared positive. So we'll keep that over here. We'll move the 8 over, and now it's equal to 0. We're looking for two numbers that multiply to 8 and subtract to 4. The only numbers that multiply to 8 are 1 and 8, 2 and 4. And neither one of those pairs subtract to 4. We're in trouble here. What are we going to do? Well, my friends, we're going to use the quadratic formula. And if you're in my class, I know you've memorized that annoying song, so let's sing it together right now. X equals negative b plus or minus square root b squared minus 4ac all divided by 2a. Sorry for emphasizing the all, but I hate it when people only put the line from here to here. It has to be the whole way. And excuse me also for my horrible voice. So there you go. That's how we're going to solve this. Of course, you know that your a value right here, how much is your a value? 1. How much is your b value? Negative 4. And well, how much is your c value? Negative 8. What's with the equal signs here? Horrible. Okay, let's throw it into the formula here. So we have x equals negative b. Well, that would be negative 4, which is positive 4, plus or minus square root b squared, that's negative 4 all squared, so that's 16, minus 4 times a, which is 1, times c, which is negative 8, all divided by 2 times a, 2 times 1 if you want. Okay, so x equals 4 plus or minus square root 16. Now be careful, there's another common mistake here. We have negative 4 times 1 times negative 8. Do you see if negative, it's going to be a plus. So you're actually going to have plus 32 all divided by 2. Darn, we've got a few more steps to go here. Add the 16 and 32, you get 48 all over 2. 48, that's something we can simplify. 8 and 6, 4 and 2, 2 and 2, 2 and 3. I think we got a couple pairs in here. We got one pair here, we got one pair here. So we got 1, 2 come out, another 2 come out, multiply them together, you get 4 coming out, and you got a 3 left in. So what we have is x equals 4 plus or minus 4, 2 times 2 comes out, 4, root 3, the 3 stays in, all over 2. Finished? Afraid not. You can simplify here. Because 4 over 2 and 4 over 2 both work, you can simplify the 4, 4, and the 2. Now, if this was like a 7 right here, if it was 4 plus or minus 7 root 3, you couldn't cancel anything, right? You have to be able to cancel this and this. All three of those have to be able to be canceled. And you can do it in this case. So divide them all by 2. 4 by 2 is 2, plus or minus 4 by 2 is 2. Keep the root 3. All over 2 over 2, 2 divided by 2 is 1, so all over 1. But what's the point of that? Just leave it. So we're finished. Here's our answer. Last one, finally, at last, thank goodness. It's already equal to 0. We can't factor out anything. Looks like Bobby Bridge, so we're looking for two numbers that multiply to 6 and add to 1. Multiply 6 and add to 1? No, 3 and 2 multiply 6 and subtract to 1, but this is add to 1. So we need to use the quadratic formula again. But I just want to introduce one last thing. Do you remember there's also something called the discriminant? Do you remember what the discriminant is? The discriminant is just this part of the quadratic formula. And what's true about the discriminant is, if b squared minus 4ac is negative, what does that mean? It means there's no possible answers, no real roots. What if b squared minus 4ac is equal to 0? Then there's one real root. And what if b squared minus 4ac is positive? Then there's two real roots. Okay, so let's just save a little bit of time here and do b squared minus 4ac, because I think what we'll find if we do b squared, that's negative 1 squared, which is 1, minus 4 times 2 times 3. That's 1 minus 24, which is negative 23. The discriminant is negative. So what does that mean? That means that there are no solutions in this case. Now, here's the thing about the discriminant that's always kind of annoyed me. Are you sitting there saying, yeah, but why did you use the discriminant on this one and not over on that one? And the answer is because I've already done the questions and I know that the discriminant's not going to give me good information here, but it is over here. So probably if this was the first time I'd ever done the question, I would have done the quadratic formula anyway and noticed partway through that there's no solution. But I don't know, sometimes you got a hunch, or in some questions it is useful to just use the discriminant. So there you go, we've covered a lot of stuff here and it's all going to be pretty darn useful in calculus this year. Welcome to the course.
I ran my mouth off a bit too much, or what did I say? Well, you just laughed it off, it was all okay.